Hey guys, so today we are going to factor to find zeros. So go ahead and write that down. And we're just going to jump in and start with an example. We're going to take everything you've been doing so far and just add an extra step. So when we have this equation, and remember to pause the video. If I start going too fast and you're like, whoa, she's going too fast, pause it, write it down, then come back. So when we have this type of problem, if our leading coefficient is 1, we're going to use our notes. So just looking back real quick at our notes, a is equal to 1. Keep flipping, a is greater than 1. This one, a is equal to 1. So when a is equal to 1, we just find the two factors, put them in, and we're going to do that. Except I'm going to use the x method. So first identify a, b, and c. So a is 1, b is -1, c is -12. We're going to have parentheses. This has to be an x to get x squared. Then to figure out what those two are, we're just going to do our little x. A times c is -12. B is -1. So what multiplies, that makes -12, but adds to make -1. I already did the work for you. It's 4 and 3. One of them has to be negative. See if you can figure out which one's negative. So when you add it, you get -1. Since we always keep the sign of the larger number, the 4 has to be negative. So -4 times 3 is -12. -4 plus 3 is -1. So these two go right here. So we've already done this so far. The one thing we haven't done is found the zeros. And the way we find the zeros is we take each part and we set it equal to 0 and solve it as a one-step equation. So to undo -4, we add 4. And here we get x is 4. On this side, to undo +3, we subtract 3. And we get x is -3. So in this case, we have two answers. We have Canvas is going to have you write it as x equals 4, -3. So this is how you would write your answer into Canvas. No spaces, keep everything right next to each other. If you put any spaces, Canvas will mark it wrong. All right, so all we're doing is we're factoring our equations and then we're setting them equal to 0 and we're solving them. That's how you factor to find your zeros. So we're just going to practice with some more. Let's do this one. Okay, what's wrong with this one? Well, it needs to be equal to 0. We have this here, so we're going to need to move it over so that we have a 0 here. How do we move the -5? We do the inverse and subtract 5x. I'm going to put it under this one because they are like terms. If I put it under here, they're not like terms because there's an x on here, so it has to go under this one. Combine your like terms. Nothing to combine here. -5, -5, negative makes -10. Nothing to combine here, so drop it down. Now that we have it here, we can just solve it like we did this one. Since the leading coefficient is 1, we can just figure out what do we multiply and add to get our numbers, put them in, set them equal to 0, and solve. So with all that said, I'm going to do with my x. So a is 1, b is, oops, right here. We need to use this one, -10. C is -24. A times C, 1 times -24, -24. b is negative 10. What can we multiply? That makes negative 24, but when we add it, we get negative 10. Well, 12 times 2 is 24, but when we add it, if we want negative 10, the larger number has to be negative. So negative 12 times 2 is negative 24. Negative 12 plus 2, negative 10. That's our two numbers we're going to use. So we have, if we want x squared, we need x here and here. And then those two numbers go here and here. Set these equal to 0 and solve. And that's how you find your zeros. To get 12 by itself, add 12 to each side. Over here, I'm going to subtract 2. Let's always do the inverse. So we end up with the x is 12 and x is negative 2. So Canvas, we want to write the x equals, and it doesn't matter the order. I can put the negative 2 first or the 12. It won't make a difference, just no spaces. Make sure you pause it here. I know I went really fast, so pause it, make sure you got caught up. All right, next example. Now we can do the x if you want, but if you notice that 25 is a perfect square, you can go back and look at your notes, flip back. Special cases, I ended up writing perfect squares as a reminder, which you might want to add to the top of your notes. So when we have perfect squares, the shortcut is, if it's a perfect square, find the square root, put 1 plus 1 minus. That is it. So then we don't have to do the x, we can do the shortcut if it's a perfect square. X goes here and here. Square root of 25 is 5. One's going to be plus, one's going to be minus. It's plus and minus because positive 5 times negative 5 makes negative 25. If they are both positives, you're going to get a negative 25. All you have to do here, set them both equal to 0 and solve. You can probably do this in your head. I'm going to finish writing it out, but if you can do it in your head at this point, you can. So subtract 5, x is negative 5. Add 5, x is positive 5. Canvas wants you to write it as like this. Once again, pause it here until you're caught up. We'll go on to, we have a few more we're going to do. This lesson ends up combining all of 5-7, those 3 different kinds, and 5-8. So you just have to be able to look at the problems and decide, what do I need to do with this? And what notes will it match up so you can refer back to them. And the first thing you should notice on this problem that I'm writing is that that's cubed and there's an x in every one. So that one we are going to be factoring, and then 3 goes into 3 and 3 goes on to 18. So we're going to look for greatest common factor. So these notes are multi-step factoring. This is where we factored a greatest common factor, pulled it out, whatever's left, then we went on and factored that. So at this point, what we would do if this was our problem, set these equal to 0 and solve. So we're just going to do just like this one here. So I can factor out, let me put it here. First, I'm going to look for a greatest common factor, and you always want to check. 3 goes into all 3 parts, and they all have at least one x. This one has 2, this has 3, but you can't take more than the smallest amount. So I'm going to factor out that 3x, and I'm going to write what I have left. So if I factor out 3x to get 3x cubed, I need 2 more x's. If I need 3x squared, I already have 3x, so I need just 1 more x. And then 3 times negative 6 makes 18. I already have the x there, so I'm not going to write another one, otherwise it will change the value. Okay, so I'm going to ignore the 3x for right now and just focus on factoring this section. And I'm going to factor it now that the leading coefficient is 1, a is equal to 1. I can just use the little x method. And it might be helpful if you watch me do it and then pause and then try to rewrite it. That way you can see how it works without trying to write as I'm writing. So I'm ignoring this. I'm just looking at the parentheses. So A is 1, B is also 1, C is negative 6. So A times C, negative 6. B is 1. What can we multiply? That makes a negative 6. But when we add it, we get a positive 1. 3 times 2. Which one is negative? Well, if we want a positive answer, this needs to be positive. So this one's going to be negative. So 3 times negative 2 is negative 6. 3 plus negative 2 is positive 1. Okay. This has been ignored and it's still being ignored. It's off here on the side. But this has now broken into 2 parts. If we want x squared, these 2 are x's. And then those 2 go in here. Plus 3 minus 2. Actually, let me color code this so you can see where it came from. Okay. Now the only difference on this problem is all 3 parts are going to be set equal to 0. So this gets set equal to 0. This gets set equal to 0. And this one does. Okay. Now we have to solve all 3. To solve this one, we divide by 3 and x is 0. To solve this one, we subtract 3 and x is negative 3. And this one, add 2 and x is 2. So on this one, you end up with 3 answers. X is 0, and it can also be negative 3 and also 2. Remember, when you type these into Canvas, no spaces. All right. Pause it here if you're not caught up. We have 2 more examples I'm going to do with you guys. So this one, 2x to the 5th power minus 50x cubed equals 0. Do we have a greatest common factor? If we do, we always factor it out first. When we do, greatest common factor is 2 goes into both. That looks weird. And we can factor out, we can pull 3 from each. So that's my greatest common factor. So I'm going to start with that. If I factor it out, what's left? Well, if I factor it out, I still need 2 more x's to have a total of 5. To make 50, I have to multiply the 2 times 25. And I need it to be cubed, and it already is, so I'm done. If you notice on this one, we have a perfect square. So ignore this, focus on this, and we're just going to do the perfect square one. Bring this down. We're not using it, but we're still going to use it like we did on this one here. So this is a perfect square. Remember when we're doing perfect squares, to get x, it's x here, x times x. To get a negative 25, 1's going to be plus 5, 1's going to be minus 5. 5 times 5, 25. Now we can set them equal to 0 and solve. So 2x cubed equals 0, x plus 5 equals 0, x minus 5 equals 0. To get rid of the 2, divide by 2. And if I take the cube root of 0, I still get just 0. This one, I'm going to subtract 5. I think you guys can probably do this in your head right now. If I subtract 5, I end up with x equals 5, negative 5, minus 5. And if I add 5, I get x is positive 5. So my final answer, we get 0, we have negative 5, and we have 5. Order will not matter in Canvas. Spaces do. I keep saying that because a lot of people keep putting spaces and it's getting marked wrong. Okay, last one. We have 36x squared minus 9 equals 0. Oh, I forgot to tell you, if you don't have this, pause it. That way you don't have to worry about rewinding it. So pause here. I'm going to go on if you're not done. Okay. So I'm going to move this up. I notice these are both perfect squares. So if they're perfect squares, I also notice though that they are both perfect squares, but I can also factor out a 9. So if you can factor out something, you always do that first. So this one I'm actually going to do 2 ways. I want to show you, I'm going to show you 2 ways to do this one. The easiest way is they're both perfect squares, so I can just automatically, this one's much faster. Square root of 36 is 6, and I need an x here and an x here. Now they're both positive because 6 times 6 is 36. If I made one negative, I would have to have negative 36, so that's why they're both positive. Square root of 9 is 3, but to get a negative 9, one has to be positive 3, one has to be negative 3. When I solve this, I'm going to set it equal to 0. And I'm trying to leave room here because I want to redo this problem for you. I mean, you can do it below it, but I'm trying to leave some room here so I can show you side by side another way in case you end up doing it the other way. So from here, subtract 3 from each side. Over here, add 3 to each side. 3's cancel out. We have 6x equals negative 3. And on this side, you have 6x equals 3. Divide by 6. Divide by 6. Reduce. If I reduce this, I get negative 1/2. If I reduce this, I get a positive 1/2. Canvas will have you write it like this. Negative 1/half, comma 1/2. This is the correct answer, but if you didn't do it this way and you factored out a greatest common factor, it works too. And this one's important for you to know because this might happen to you. If I took the same problem, and if you look, the greatest common factor is 9. And I'm showing you this because there's lots of ways to solve these problems. There's not always one way. So if you do it another way, you can still get the same answer. Okay, so I factor out a 9. What do I have left? Well, 9 times 4 is 36. And then we need an x squared, so we have to add it. 9 times what gives me negative 9? It has to be a negative 1. Okay? These are perfect squares once again. 4 is a perfect square, 1 is a perfect square. Just like the other problems, I'm going to bring the 9 down, but I'm going to just ignore it because we're not doing anything with it. Okay, square root of 4 is 2, so 2 goes here and here. To get x squared, we need an x here and here. 2 times 2 is 4. That's why they're both positive, because we want a positive 4. To get a negative 1, we have to have a positive 1 and a negative 1. Now at this point, I set everything equal to 0. And if you notice, when I set 9 equal to 0, is 9 equal to 0? No, it is not. And that's why 9 is not part of the answer. When I set these equal to 0, 2x plus 1 and 2x minus 1. When you solve it, subtract 1, subtract 1, add 1, add 1, cancels out. 2x equals negative 1, 2x equals positive 1. Last thing, divide by 2, divide by 2, divide by 2, divide by 2. If you notice, our answers match up, negative 1/2 and positive 1/2. The difference is if you factor, you're already going to be reduced in simplest form. This one we didn't factor, so we ended up having to reduce it to simplest form. So once again, if you ever end up with a number equaling 0, it's not true. 9 does not equal 0, so this will not be part of our answer. So our answer in Canvas will end up being just written exactly like this. 9 is not part of the answer because 9 does not equal 0. All right, you guys are now ready to start the homework.